Welcome to the Bytecode. I'm your host Shafu, and today's episode is with Austin, who's gonna walk us through Scaffold-ETH V2. Austin, GM, sir, how are you doing?
GM, thanks for having me. Doing very well. How are you doing?
I'm great, dude. I'm excited for you going through Scaffold-ETH V2 today.
Yes, heck yeah, me too. Should I just get started? We've got Build Guild up here. Maybe we can talk about that for a second and then dive into Scaffold-ETH and start building something.
Let's do it, sir.
Awesome. Word. Okay. So I think mostly today we're going to be tinkering with Scaffold-ETH. I know that your audience is very technical and they're already building lots of smart contracts and doing gas optimizations and all the cool stuff that low-level Solidity developers do. But now and then you need to build something that has like a user interface, right? And we're going to talk today about how you can take your heady, cool contracts and actually like quickly build an app around them that people can use. But let me just back up to shield the Build Guild just for a second. The Build Guild is an organization where we are giving small grants to people in the ecosystem. We're building tools like Scaffold-ETH 2, and we're also doing a lot of educational stuff. If you are a new developer or you know new developers that are coming in, like someone who's a good Web 2 developer or a DevOps developer, and they're still like trying to figure out how to get into Web 3, I always want to shill Speedrun Ethereum to them because this is just a really good technical resource that will take you through, why and how to build on Ethereum, and you're going to use Scaffold-ETH all the way through. And we're gonna use Scaffold-ETH here today. And I think let's just get started and start hacking on some code. I know at this point most of your shows, you guys are already into the bytecode or something by this point, so this will be a little bit slower. We'll get started, but here we go. So with Scaffold-ETH 2, you can clone it down. It's a repo, or you can kind of do this choose your own adventure kind of NPX thing, and we're going to do that. So I'm going to do NPX create ETH, and then we can come up with some kind of build. I was thinking about doing like a delegate build. I don't even know. Like I want to do some kind of like maybe even like poor man's bonding curve or something. I don't know exactly what we're going to build here. Who knows? We're going to say who knows. That's going to be the name of our app today, the Who Knows app. And this is our first question, right? I think there are a couple 50-50 questions still in Ethereum. Knowing that your audience is very technical, they probably are more Foundry than hard hat nerds at this point. So we'll go with Foundry. Is that your gut feeling on it too? Is that Foundry is probably the favorite for your audience?
Yeah, we had 26 episodes so far. I don't think we had one hard hat repository.
Damn. So it's definitely
Yeah.
not 50-50 for your audience. It's almost 100%
No.
Foundry. Is that
Yeah.
right?
Yeah.
Cool.
Yeah.
Well, so yeah, Foundry's great, obviously. Like being able to write your tests in Solidity to test your Solidity, having that just like run faster, right? Just like the overall speed improvements. But there is something about Hard Hat that is really handy for app builders because you're basically prototyping all of your contract interfaces by writing tests in JavaScript. It sounds bad to people who are only living in the Solidity world, but I promise you having these JavaScript tests is actually very valuable if you're also building an app to go along with it. So there are some pros and cons. And by the way, like when we just had Truffle and Hard Hat came along, they totally changed the game. Like Truffle was awful and it had all these confusing commands where you were migrating and it didn't make sense. Hard Hat came along and not only did they make their tool better, but they like cleaned out some of these dependencies that were giving people's problems on install. So still shout out to the Hard Hat crew. They did change the industry, but I think now we are seeing a lot more highly technical people move to the Foundry side. So let's get into old Who Knows and get this going. So we fired up a repo, right? We pulled that down, and now it's going to let us run some of these commands. I'm going to do a yarn chain back here, and that's going to bring up our Anvil chain locally. And then I can yarn deploy from this terminal maybe. And that's going to deploy just a placeholder smart contract, basically. And then if we do yarn start, that's going to bring up our front end. And this is where you can see that Scaffold-ETH kind of provides this scaffolding, right? Again, scaffolding is something you kind of build up around a building, and it's ugly at first, but it helps you construct the building, and then when you're done with the building, you kind of bring down the scaffolding, right? So there are some things that you'll carve out of Scaffold-ETH as you go along, and it may look a little bit like there's too much there, but I promise we've been building apps for years without taking out things that we need. And this is kind of the key page here where you can debug your smart contract. It's really nice because you can have this nice interface over here, and then we can bring up our code over here and have those two things side by side. And let me show that right here. So if we get in here, we have a Foundry and an Next.js in a single package. And if I go to Foundry contracts and look at our contract, it's going to be kind of small. I'll try to make it a little bit bigger. But then when you get to this moment where you have basically your smart contract on the left and your app on the right, and you can add some new things, right? So let's make an address public delegate, I think is a demo that I do a lot, right? We bring a delegate in, and then if I go ahead and yarn deploy that again, we're going to see a new value show up over here, which is going to be this new delegate. There we go. So now there's a delegate on our smart contract, and we can see it. And this feedback loop is very powerful. If you're building a smart contract app that you're going to want people to use, you can get into this really nice feed. We created a delegate address, we created a set delegate function, and now we can come over here and try calling it and see what happens. And you can kind of get in this really nice feedback loop where it's like, okay, now there's this set delegate, and I can set that to, ATG. Oh, got to get some gas from the faucet first. But there we go. Now I set the delegate, right? I can get this really tight feedback loop where I can try these things. And let me show you where that's really powerful. Let's say there's obviously, like, anyone can call this set delegate. Your audience, the back of their neck should tingle when they see there's no modifiers on here and no requires, right? Basically, we're letting anyone in the whole world set this delegate. So we probably need to bring in something like this isOwner modifier to add to that, right? And this is always a good chance to talk about how this isOwner modifier is built here for you, and you can see it, and we can test how it works. But you probably shouldn't be building your own. You could just import OpenZeppelin's ownable, and we could inherit it, say is ownable here and be done. And we kind of have that scaffolding there. Notice it's right there, and it's commented out, and it's ready for you. That's what Scaffold-ETH does. Is it's like thinking ahead to what you're going to need to do, provide that scaffolding. So when you get there, it's like a simple, oh, this is an obvious thing for me to do next. So what I want to do is I want to test this right here, right? We just created a new delegate and added this isOwner modifier. Now, I could write a bank of tests that would test the fact that a good guy who's an owner can set this thing and a bad guy can't set this thing. But it's going to take me 15, 20, 30 minutes to write that whole test bank and run it and make sure it works. Let's, in just 1 minute, test that it works, just to test our assumptions, right? So I've redeployed this now. The delegate is back to 0. And if I try to set the delegate to ATG .eth, it's saying not the owner now, okay? Oh, this owner is actually it's like the 0 address from the chain, right? When we run this Anvil node, it gives us a bunch of private keys. And that's one of those private keys is basically this nice faucet you have here where you can send yourself, millions of dollars from this account. So if we kind of backtrack a little bit, we find that in the Foundry script for deploying, we're probably sending in some address. Yes, look at that. And if we go look at our smart contract, we probably see that there's a constructor that address is coming in on. So let's just go look at that real quick. What can we put in here? I think I need to do address. I'm bad at Foundry. I think I want to do address and then copy this guy's address and paste it in and hit save. And then let's redeploy again. Let's see if it likes it. When it yells at me, I always imagine Georgios yelling at me in his like deep Greek voice. What are you doing? You're doing it wrong. There we go. Okay, so it deployed, and now we're the owner, right? Very quickly, we're iterating on our smart contract. Now we're the owner, and now we should be able to set the delegate, right? Let's see if we can make Vitalik the delegate here. Yes, it worked. Okay, so we tried both kind of the sad path and the happy path. We tried with someone that wasn't the owner. We updated it so when we were the owner. But let me show you one other thing, and this kind of highlights burner wallets. One thing that's really nice about Scaffold-ETH is you don't have to do MetaMask right away. MetaMask is always going to give you an error about like you're on the wrong chain ID or your nonce isn't right for the right chain ID because you're trying to use MetaMask on localhost, and it's just a huge headache. But with Scaffold-ETH, we use burner wallets. We throw private keys right in local storage, and we sign messages without popping anything up, which is very, very dangerous on public real money networks, and you shouldn't do it. But on a local host where you have tons of money, it just makes sense. It makes a lot more sense. So we're bringing in this bad guy, and we're funding him from the faucet, and we're going to this debug page, and we're trying to set the delegate to something else, right? We want to see if this guy can do that, and he doesn't. He can't. He gets the not the owner. So just within that like minute or two, we're able to test our assumptions. We're able to make sure that some nefarious actor can't get in here and set the owner. And we're not for sure, right? Like we're not 100% sure that this is perfectly working, but we tested the 2 or 3 different use cases that we can think of. We kind of went down the happy path and went down the sad path. And this does what we think it's going to do. Of course, before you go to production and put a bunch of money in this, you need to audit it and you need to spend a lot more time on it. But as a developer who's building an app that you want to get into people's hands and kind of get some feedback of how they use it, this is just a really nice, tight little dev loop that you can get in where you're just making small changes to your Solidity and then kind of poking at it from the front end. Is that pretty clear so far? Is that do you have any questions, or should I just keep rolling with it? What do you think?
No, that's was a really cool demonstration, and I really like the tight feedback loop. Just a general question, Austin. What's the difference between a V2 and V1? The main differences.
That's a great. Yep. So if we go look up Scaffold-ETH, there is an old Scaffold-ETH that is this one. That got a lot of stars. It has more stars than Foundry or Hardhat, which is crazy. But we decided to retire this one because it was mostly built by me. And while I am a great prototyper and tool builder, I am not a clean, tight, nice tool builder. My tools end up being very messy, right? So after we were able to say, okay, Scaffold-ETH is getting traction, almost 100 contributors here, like almost 9,000 stars, lots and lots of people are forking this thing. It has kind of like this Lindy effect that a lot of people are using it, forking it for making their prototypes. But a lot of the feedback we got there, it was very messy. Maybe it didn't feel like it was production ready for folks. So what we did was just take this idea of Scaffold-ETH and rebuild it in Next.js with TypeScript, and we built it just very clean, and it just looks a lot better and works a lot better, and it's just more production ready. And that's Scaffold-ETH 2. So the TLDR is just Scaffold-ETH was more of a prototype. Scaffold-ETH 2 is more of a finished product. It has a good team of developers supporting it that aren't me. Like I don't get in there and make a mess with the thing. I'll put a PR or an issue in now and then when something goes wrong, but most of the time we have a good technical team working on it, supporting it, keeping it up to date, keeping the latest things in there, keeping the code nice and clean. There's so many really nice things that you can do with that type safety. Let's look at that delegate right there. If I were to be working in my front end, the fact that I have this delegate here, as soon as I add it to the smart contract, my front end's going to be able to autofill those types. And we'll get in there as we start building a front end in a second. I think that's like maybe the next step is like we tinker around with a smart contract, and then we're like, all right, let's build the app for people to use. But does that answer your question about Scaffold-ETH 1? Does that kind of clear that up too?
Yeah,
cool.
Great answer.
Cool. Okay, let's play with this smart contract a little bit more to understand what else is going on. It's kind of a classic greeter contract where we're storing a greeter. Looks like there's some other values here. I think what we're doing here is just showing you the primitives, right? The primitives of Solidity as a language. You should kind of know these primitives pretty well. There's examples of events, how the constructor works, example of a modifier. And there's really only one function here, and this is a set greeting. and it's payable. And there's this kind of interesting little piece of logic here where we're looking at it and we're saying if message.value is greater than 0, we set some premium flag, right? And we can go kind of tinker with that in the front end here too. Where's our local host? Right now we see premium is false, and we set some greeting, hello world, and we hit send, right? And now our greeting is updated, but premium is still false. And so what do we have to do to get into here? We have to have message.value. Okay, let's test it. So let's set this to one way, and let's hit send. There we go. It worked, right? So this is going to illuminate another really aha moment you need to have as you're getting into and starting to write Solidity, is that when we say one right here, it's one way, right? So if I do a 2 here, it's going to work, but if I do a 1, it's not, right? But what we really want, one way is nothing. It's insignificant compared to the gas you're going to have to pay to make the transaction, right? So this is obviously something that would be a good first thing to change. And really we want them to maybe send in 0.001 ether, right? And that's going to change what this looks like in the front end. But let's go ahead. I want to do greater than or equal to, just because it's a little easier. There we go. Now let's deploy this thing and let's go poke at it and see, does it work the way we want it to? Does it actually charge us that 0.01 ETH, right? So let's get in here and let's say, hey. And then let's do 0.001. Okay, now this is going to throw an error and I want to show it to you. It cannot convert to big end. This page right here that we're seeing, this is built for developers. This is assuming that a person who's going to land here and tinker with this UI is someone who's probably working on the smart contract, or probably someone who's part of the team of someone who's going to work on the contract. We have all these builds out in the wild, but if you go to /debug, instead of this nice hacker house page, you're going to get this debug page that is exactly like this, where you can still have this nice interface to poke at whatever this live contract is, do a read or write from here. By the way, if you're doing that, you should use, let me grab this. You should use ABI Ninja. Let me show this quick shill built with Scaffold-ETH too. But look at this, that same contract. I'm going to load that up and I'm going to get a really nice interface that's going to let me kind of set that up. And then I can send that in a link to someone and they'll have this exact interface. So yeah, if you're interfacing with the contract directly in Etherscan, you should definitely use ABI Ninja or something better than just Etherscan. But okay, here we go. So we've got our hey here, and we've got our 0.1, and that's not going to work for a normal developer, because what they need to do is they need to learn about the difference between ether and way. And this is one of those moments where your audience has probably done this a million times, but a brand new developer is going to have this aha moment where they have to multiply by 10 to the 18 to get it from way to ether. And there you go. So now you have that, which is actually equal to this 0.01 ether. So we should flip the premium bit when we hit send. There we go. Now premium is true, and you can see that worked. And this is kind of ugly and messy, but it's ugly and messy and obvious to the developer because they're kind of still poking at this and trying to understand this. If they tried to do 0.001, they're going to get an error. They just have to know the difference between ether and way. And we feel that having it like this in the user interface is going to help teach them and prepare them. And it's really annoying because you get in here every time and do that and you're like, oh shoot, oh yeah, I got to hit that button and hit send, and then it works. But that training of the developer is helping get in the right mindset of how these smart contracts work. Okay, so we've tested out our smart contract. It looks like there's a withdraw function here. We can see that there's money, there's $5 in this smart contract now, and there's no way to get that money out. So we've added a nice little withdraw here. So probably only the owner can withdraw. Yeah, there you go. Then the money's out of the contract. Cool. So that's the whole smart contract. Not much to see. A very simple, very obvious, starting hello world greeting contract. I kind of like this idea of this delegate. And I was thinking what we would do is have the money go to the delegate instead of landing in the smart contract. So maybe we could go to this set greeting thing and we could, send all the value to the delegate. Now let's see if, oh, it did. Look at that. I was seeing if Copilot would do like a send or a transfer. You don't want to do that. No, no, no. You don't want to do a send or transfer because of the gas limits, right? You want to do that call so you can make sure you can send it to like a Gnosis Safe or some kind of smart contract wallet that has a fallback function that burns more gas than is in the limit of the send. And it did. Did it perfectly for us on the first try. We could even maybe require a success. I don't know. Should we? Yeah, let's go with it. Thanks, Copilot. And then let's deploy it and let's see if it works. Okay. And let's reload that. So then we're looking at, okay, so we need to set a delegate. Let's make a new incognito window. And, blue guy. There we go. We got a nice blue character here, right? Has 1 ETH in Foundry. But if we set them as the delegate, so we copy this address and we hit paste. Notice you got that nice visual of that block key. We'll get into these visual components in a little bit, but just pointing out how nice that is, that I can visually see there's the blue guy here, there's the blue guy here, and now the blue guy is the delegate. Just real quick, I can visually see that address is right without having to have some ENS name or something for it. Now what I want to do is I want to set the greeting, hey, and I want to pay, 0.1 ETH or something. We want to see a bunch of money come through here. And what happens if I send that? Does this guy get his 0.1 ETH? He did, right? We see 1.1 ETH there now. And there's no money in the contract. So we were able to very quickly make a small change to our contract that completely changes how the money flows and then test it with the front end without having to write a huge bank of tests. But at this point, now you should start thinking about writing a huge bank of tests, right? But let's just kind of prototype this thing a little bit more. I kind of like this as being a variable too. What if we have a price here, right? And then up here we set some, let's do 0.001 Ether. Okay. Now I'm going to do something crazy here. After someone pays, I don't know about this premium thing anymore. Let's see. Oh, this is just for premium. I see. How about we even require it? I kind of want to get rid of premium, and I want to set up a require statement up here that just requires that it's greater than or equal to the price. And then what I'm going to do is I'm going to make a little bonding curve here. We're going to say price equals price times 105 divided by 100, right? So 5%. Oh, look at that. Yeah, heck yeah, give us that. I'll take a comment. Yeah, increase the price by 5%. Now let's go see if this works, right? Let's go deploy it. And hopefully now our delegate is going to start getting more and more money, right? The price should go up as we set these. So the starting price is right there. And if we just put exactly that amount in and we hit send, now look at that. That price went up, right? Now that price is up 5%. And if we were to pay the not 5%, it should yell at us insufficient funds. Wait a minute, that's a different problem. Oh, well, we have plenty of funds. Insufficient funds is not the right. Oh, it's because we have it in our require statement, right? It's saying that, yeah, you are not paying enough, not insufficient funds, right? Let's get a better error there. And really, I'm sure your audience is also getting goosebumps here saying you should be using custom errors and not paying gas for require strings, right? But I'm old school. I'll get over it. Teach an old dog new tricks soon. But now, okay, so what we want to see is, does the price go up and do they get the right error? When I hit this now and I hit it again, you're not paying enough, right? So let's grab that price and paste it in. So now we've added a few things to this contract, right? We've created a delegate system. We've streamed the money to the delegate instead of letting it show up in a contract. And then we basically built a price curve around the cost. And we kind of added all these features in, but now let's freeze our contract, I think. I think our contract is good enough. Maybe there's some holes in it. You would want to write a lot of tests. But let's say we've iterated back and forth. We've dinked around with our contract. We've used this like nice developer front end to make sure this all works right. Now we want to create like an app. You would want to actually create the full-on front end for this that doesn't look like this, that looks a little bit better for your users. For instance, if we had a set greeting UI, we would not have them put in the number in way. We would say, 0.001 or something like that. It would be clearly, they would be operating in Ether, or better yet, what you do is you have your app use USD. Right? It's way better if you can look at the USD value and use that. So let's see. Do I even have something that does that? No, I don't. Okay. So when you're ready to write your front end, and I think we are. What do you think? Any feedback so far? Let's go. I got a yes. Okay. So we've tinkered around with both our front end and our back end. We've got our contract pretty solid. Now it's time to really kind of lay out the React. If you're building apps in Ethereum, it's kind of sad, but you do spend like as much time writing stupid React as you do writing the cool Solidity. But let's go write some stupid React. More time writing stupid React.
More.
Yep. Well, the goal of Scaffold-ETH is to try to speed that process up as much as we can and give you a handful of components and hooks. By the way, we had ETH hooks and ETH components, and along came WAGMI, which was so awesome. And we just carved out our hooks, and now we use WAGMI all over in here, and we'll see that in a second. So here's the Next.js side, right? We were spending a lot of time in the Foundry side. Now let's kind of move over to the Next.js side. We're using app routers instead of page routers now. So we'll get into our app and we'll look at this first page. And here it is. Let's just go ahead and clear out all this stuff. We don't want all these divs. There we go. Something like that. How's that look? We should get kind of nothing over here, right? Should kind of hot reload to be nothing. Okay, and can I put like a hello world in there just so we see it? Yeah, there we go. There's our hello world. Okay. So Next.js is super fast. It's using TypeScript, so we get all this type safety. We got all this hinting, and I'll get to that in a moment. But there's this weird thing where if the state of the app on the server is different than the state of the app on the client, you get all these weird errors. And so what we're going to do here is quickly, we're going to need to make a change. Let's just see the error real quick. So what I want to do, first thing I want to do is maybe set up the address. I just want to display the address of the person who's logged in on my app. It's like, that's like the first app you ever build is like, let someone connect a wallet and display their address, right? Let's do that real quick. So we're going to have some address and we're going to use WAGMI, right? So I'll use account is a WAGMI hook. And let's say I didn't know what comes in here. Let's say I just know there's this use account and I want to do this. What I can do is just hit, what is that, control space for me? But it's probably control or command space depending on your keyboard layout. But look at this. I just get this nice stuff right away. And I know, okay, so I want the address coming from use account. And then let's go ahead and display that address here. But it's going to yell at us. We're going to get an error here when I hit save because Webpack explodes and it's like, and it gives us this weird error. But really what's going on is you have to do this use client thing up here. And Scaffold-ETH 2 is going to get better and better about showing this use client and exposing this to the user. But that's one of the first things we have to do is if we're going to be making a lot of custom changes here and the server, so the client side rendering is going to end up being different than the server side rendering. You need to do this use client up here. But now we've got it set up, right? We have this simple little app that is grabbing the address using WAGMI. We're grabbing the address of the logged in person and we're displaying it here, right? Very good, like hello world app for building your first smart contract app. So let's make that look a little nicer. Again, we try to give you as much out of the box as we can. Instead of displaying this as this ugly address here, how do we make it look like one of those nice addresses? And what you do is just bring in an address component, right? Address, and then, I can do the command enter thing. It looks like it was trying to just tell me to do it. Yeah, address equals, and it equals this thing. And there we go, like that little change. And now, look at that. Now we have this nice looking address here. And this isn't just nice looking. This thing has a lot of functionality underneath this abstraction that you don't even know is happening here. Let me look at this scaffold config file to help illustrate this. Right now we are on Foundry, right? But if I were to switch this to, Optimism or something like that. My entire app with that one little change is now on Optimism. And I can connect my wallet, and there we go. We see hello world and we see this guy logged in. But look what happens when I click this. If I click on this, it's going to take us to the Optimism block explorer, right? So you make one change to your code and your entire app switches over to being on that network, including all these little things like this address component linking out to the right block explorer. But also, like, just look how nice this looks, right? You have your ENS profile replacing the blocky. You have ENS name come in here. You can have this nice little copy button to copy the address, or you click on it to go to the block explorer. Just that's how a DApp needs to work. Like every address component in a DApp should probably be very, very similar to that. So we're trying to provide these components out of the box for you so you don't run into these problems eventually. That thing right there, see that switch network? If you're building an app, your users are going to accidentally come in and they're going to have their MetaMask on the wrong network. And if you're building an app, you're going to have to deal with all these edge cases where you're checking the network and then bumping them over to the right network with a nice little button. You have to build that into your app. And if you don't, your users are going to get into all sorts of problems, and you're not going to realize you need to build that thing in until you already have users. And that's why I'm saying you can front load all these problems by just using Scaffold-ETH from the start to prototype, because all of these little things are going to be fixed for you. Let me log out though. No more MetaMask. Let's get back to that burner wallet. That burner wallet's really nice to have. And now look what happens when I click on my address. It's going to take me to, I think, a local block explorer. Let's see. Yep, look at that. So there's even a local block explorer built into Scaffold-ETH that helps you kind of figure things out on your local network before you even go to a public network where you have a public block explorer. Okay, so what else can we do with our app? We have, let's go back and look at this. We have, maybe you are, and then we show this address, right? Let's see how that looks. There we go. Okay, now let's make another div. And now we want to say the delegate is, and now we need the delegate address, right? Let's go back to debug contracts and look at that. It starts as zeros, but it's just a value that we can read from the smart contract. So now it's time to read our first value from our smart contract. Again, if you're making a hello world app, usually you display the person who's logged in first, you do a read from the smart contract second, and then you have a button that writes to the contract third. And if you can make a little starter kit that does all those things, you're off to the races. And we're going to do that here. We're on step 2. So how do we read from a smart contract? You can use WAGMI. Again, like anything from WAGMI, you can go read their docs. VM and WAGMI come in with Scaffold-ETH. So you could use the use contract read hook from WAGMI, but we've even wrapped that in something nicer for Scaffold-ETH because we handle all the wallets and a lot of other abstractions for you. So you could use this really long function called use scaffold contract read. It's a mouthful, but it's a very powerful function. Let's see if I do this, and I think it's going to tell me I need the type safety should, oh, wait, did this? Oh yeah, it came in. Okay, there it was, right? What we need is an object that has your contract. Let's see, maybe it'll have your contract and then I really wish, I guess it's just going to fill it in. Well, it doesn't like function name. Let's see. Yeah, it is function name equals. Oh, okay. Here, this is a really cool part. Watch this. So you're writing your front end. You've already finished your smart contract, and you're like, what was that variable for the delegate? Now I can go look at the contract, but if I just start typing here, it's going to be like, oh, delegate, right? Here are all of the items from the smart contract, but right here in the front end, I don't even have to go back to the smart contract. I can kind of just let the basically Copilot and the type safety stuff just fill in almost everything I need here. And then so what's coming back from this function is some data, and we can rename that really to delegate, right? So now let's see if we paste this in here, if our front end changes. Yes, it did. Look at that. There we go. So we're logged in as this person, and we're reading the delegate from the smart contract, which is right now the 0 address. Now what we need to do is display what? Maybe the admin? Who can set the delegate? I think it's only the owner can set the delegate, right? So let's do a second read, and we'll get the owner out of this too. And I'm just going to do owner, and I think it's just owner. Yep. There we go. And then we drop owner in, oh, and we copy this too. And we say owner and owner. There we go. All right, this is looking really good. So we're logged in as this person. This is the delegate. This is the owner. If we're logged in as the owner, we should be able to set the delegate, which now moves us on to part 3 of building your first Hello World app, which is that writing to the smart contract, right? And guess what? With Scaffold-ETH, we got a hook for you. You're going to do const something, and we're going to say use scaffold contract write, right? And we're going to need you to write some value in here. And that's going to be your contract. And what is the function we're going to want to call here? It's going to be something about like set delegate, right? Let's see. Is there a set? I don't think we imported this. Yep. Now if we import that, do we get the set? There we go. Okay, we hadn't imported it yet, so it didn't give us our functions, but now we have our functions here. We want to call the set delegate function with some args. There we go. And it will be the address, like our address. Okay, so this isn't exactly what we want it to do, but let's go down this little rabbit hole here. And so what comes back here, what we're looking for is this write async function. We're going to borrow that, and we're going to call it set delegate. So now anywhere in my code, I can just call set delegate, and it's going to set the delegate to my address, which isn't the best, but let's just go make sure that works first, right? Let's get another div here, and we'll get like a button going. Oh yeah, on delegate, set delegate. That looks great. And then let's close that. I think what we're going to be missing is, yeah, it looks ugly. Let's make that look a little bit better. Let's do a class name. And here's where you spend a lot of time in React, right? Like freaking throwing button classes and button primary. But now we get this nice primary button, right? And I really want more padding. Give us like 10, right? All the way around. Oh, that's nice. Yeah. Okay. And the on click, it's saying it doesn't like it. What happens if I click it? It actually works, right? It sets the delegate to the thing. So I don't know what it's complaining about here, but we'll do that in a second. But we don't really want it to set the delegate to whatever the address is. What I'm trying to build with this UI, and I probably should have been clear about that from the start, we're not going to worry about any of the greeting stuff. We're building a small UI that would be part of a bigger UI just to show off what building the UI looks like. But this UI, the purpose will be, I want an admin to be able to come in here and set a different delegate or establish who the first delegate will be. And so I want them to be able to come in here, put in an address, hit set delegate, and let them set it. And right now we're not letting them put in a custom address, right? And that's going to bring in this new component, which is really handy. Let's maybe grab all of this again. And we'll say set new delegate. And instead of an address, we're going to use an address input. So just like the address component, Scaffold-ETH has a handful. I kind of like that first one. It has a handful of components that you will use. There we go. I like that. Let's see. We'll get to that in a second. Address input. I think I need to add that in there. I don't think I want to autofocus it. I don't need that. Maybe I can just do set new delegate. Yeah, and then value will be kind of some new address. There we go. So it's working pretty well. We have this. I can type in. Oh no, I can't type anything because the state is not in control yet. We need a controlled state. So I think the Copilot will figure it out if I say something like new address, right? We want the value to be new address, and then on change it'll be like set new address, and I'm just like randomly naming those because now I think Copilot will be like, okay, you have that address down there. Nope, that's not what I want. I want something like this. There we go. Use state. Oh, there we go. Man, Copilot really lets me drunk drive through my coding. It's really not a safe practice. But thank you, Copilot, for taking care of all this stuff for me. So then we get down here and we need to set new address. I think there's some value that comes in here and we'll set it there. That's probably what it's yelling at us for. And then up here, on our set delegate, we need whatever address we want, right? So we need new address there. And I think maybe I need to move this up above that. There we go. So we track this state variable new address, and then we have a hook that lets us call the contract with that new address, and then we just call that when someone pushes the button. But I think it wants us to do one of these. Oh, what's that function called? Set delegate. Okay, cool. Okay, I don't think we have any red anymore. I think we're happy. Oh, that's good. Prettier is happy. Okay, so now this should work, I think. I think we have the full working front end and we can go test it. Let's redeploy our contract so we get a fresh contract and a fresh delegate. Okay, there we go. So delegate is 0. Here is us. And we want to set a new delegate, right? Let's have it go to Vitalik. Anytime anybody sets the greeting in this contract, oh, this is really ugly how this button is over here. And I'll spend as much time trying to center this button in this div as I do writing all that solidity I did earlier, making sure that works right? I'm not even going to try to center this button. But it's a tailwind. What you would do is look up tailwind, center, div, something like that, and Tailwind is going to tell you how to do that. If you're looking for components in Scaffold-ETH, it's Daisy UI if you wanted to do like a grid system or something interesting. So we use Tailwind and Daisy UI, and you can bring those components in here. A smarter man than me will easily be able to center this button, but I'm joking about how hard front ends are. But I think we just set our delegate to Vitalik, right? This all seems to work, and this is kind of what we wanted it to do. Let me think about if there's anything else we want to do before I push this thing to production. Maybe we even do the set greeting, right? How about we do a little field? That's too much work. I'll spend way too much time just building a little bit more front end, and I think we've actually showed off all the front end stuff you kind of need. Those three things, right? Like showing the address, reading from a contract, writing to a contract. We've covered that here. We get your address using WAGME hooks. We read data using Scaffold read, and then we write data using Scaffold write. And you're probably going to have to track some state variables within your app. But this is like pretty much the simplest but clearest, like good starter kit for our apps. I think we're pretty good here. I think we're about ready. Maybe we push this thing out to production in a second. Do you see us missing anything, or should we go for the full deploy? All right, awesome. So let's see. We've got our app and we're deploying it. Currently, we're deploying it to our hard hat node. And so it's basically free. We have this 1.0 account that has tons and tons of ETH. If we want to deploy to a public network, we're going to need to generate a deployment account. Now, if you've done deployments before, you probably have put a private key in an environment file. And if you've done it really wrong, you maybe have that private key in your MetaMask too, and you've copy pasted that thing around, and man, that's scary. We don't want to do that, right? We want to have a private key that we never see, and it only holds enough money to deploy our contract, and we only use it that one time. So we like really like you're just minimizing the chances. And so if you do a yarn generate here in Scaffold-ETH, it's going to create you an account. It's going to hide it in an env file that is already hidden in the gitignore. So you would have to like do some serious work to get this private key exposed. And again, this private key doesn't have any value on it except for if you send it just enough to deploy a smart contract or something like that. And I can do yarn account, and I can see that account even closer. And what I'm going to do is I'm going to send it some ETH, and we'll deploy this out to a public network. We could go Sepolia, Goerli, any of the L2s, Base. I kind of like Base recently. Have you been using Base at all? We really shouldn't put this smart contract app on a public network for real money. Like, don't do this in practice. I'm just showing you how it's possible. But let's deploy to Base if I can. Let me try to deploy this to Base, and we'll see what happens. So I'm going to pull up my smart contract or my burner wallet here, and I happen to have 0.5 Base. I've got a little Base going on here, so I'm just gonna send this dude a little Base. And let's say, I don't know, maybe like $10 worth of Base. That should definitely be enough to deploy one smart contract. So 0.0034 ETH was just sent to this address. And if I were to kind of look through these again, base is here somewhere, we'd see some. I'm going to assume that everything is ready to go. So we're going to do a yarn deploy, just like we were doing locally, right? This yarn deploy would ship it off to Hardhat, or ship it off to the local Anvil node. I guess we're in Foundry, not Hardhat. But what you can do is just add this network flag here and type in any network you want, and it's going to work, right? Let's do base. So maybe this is going to work. I hope this works. Please work first try. We're going to try to deploy our smart contract to base. Let's see what happens. Please work. Oh, it's working. It's working. It's going.
Nice.
Hopefully that $10 was enough. It's got to be, right? On base, I bet it's like $4 or $5 to deploy this, right? Ooh, we can even see. Oh, wow. No, that was super cheap. That's awesome. Wow, I didn't think that it would be that cheap. Let me see how much money I have left over in that account. Dang. Okay, no, that's a distraction. Don't get distracted. Let's go. We just deployed our smart contract to a public network. So technically, we've deployed a decentralized app, because someone could technically go to Etherscan or ABI Ninja and they can interface with our smart contract. Our smart contract is out there and it's public and people can get to it. Hopefully it's verified. I don't know if it's verified if it goes to base. I think maybe we don't have a base API key in here, so you might have to manually go verify that smart contract, which is kind of a pain in the butt. A lot of times coming out of Scaffold-ETH, it'll be verified. But okay, next step here. We've got it deployed to base, but look, our app is still on Hardhat, and it's still talking to whatever the Hardhat smart contract is. There's one other change you need to do to this to point everything, and we saw that earlier. It's right here, right? We want to go to chain.base, and I'm even going to speed this polling time up since base is a real fast L2. And just like we saw earlier, I'm going to allow burner wallets too. Don't normally put burner wallets on a public network, but this burner wallet happens to be the owner of this smart contract, so I'm going to allow burner wallets in my app even on public networks, which is a bad idea. But here is our burner wallet here, and here is our contract. We can click here, we can go see our contract on a public network. It isn't verified. That's sad. We'll need to patch that in Scaffold-ETH too, so this kind of thing just shows up and it's verified. But this is the basics here. We've already deployed our smart contract, and now we change that one variable, and now our app is on base. So everything here should work exactly the same, and we're ready to use our UI, right? So let's try it. We're logged in as this person. This person's the delegate. This person's the owner. I'm going to make our new delegate atg.eth. I'm going to make it my address, just in case if I send it money, I can like pull it out. I'm not sending like 25 cents to Vitalik and annoying him or something. But let's see what happens. All right, so we're about to make a mainnet based transaction here. So this is actually going to cost real money when I click this button, and we're not going to get up any pop-ups. It's going to sign the transaction and ship it. So this is why you shouldn't probably be using burner wallets unless you want people to just have like one-click access to transactions, which has its benefits, but also is very scary. But here we go. Let's see if we can set the delegate on mainnet base to atg.eth using our brand new UI that we built, backed by our public smart contract on base that we just built and created. There it is. It's ready to go, right? So now if people get in to use this, let's say we probably have another UI for setting the greeting, but now people can say, hello. Let's actually even connect. No, because I want to send money. Yeah, okay, let's just say someone comes along and sets hello world, and they have to pay now, right? They have to pay this much, which I don't even have. Yep, okay. And then if I did have that much money in this account, we would see the greeting update. We would see the price. Remember, we put that price on a price curve. We would see the price go up 5%. And all of this is on a main public network that anyone in the whole world can get to. It's censorship resistant. It's a decentralized app. Everything is here. We're still on localhost though. So maybe we should ship this app to Vercel and get it fully pushed. But all you have to do there is do yarn Vercel, and there's some extra flags out here, a YOLO prod, which is like, don't look at checking any of my types. Don't give me any kind of like warnings on anything. I want you to YOLO this thing all the way to production without, and I think we called it who knows, right? So, oh no, wait, someone already has who knows? Dang. Who knows two? There we go. Oh, project not found. Oh, wait, what is the name? Oh, no. Oh, shoot, I did that wrong. It's not an existing product. Let's do that again. I answered the questions wrong. Yes, I want to deploy it. Yes to there. No. No. There we go. Who knows? And then we just kind of go with the defaults. There we go. Yeah, send it. So now our front end is building, and this will eventually deploy to a public URL. So within, 45 minutes, we were able to tinker with our smart contract, write some Solidity with some front end feedback, and get that nice dev loop going. Then get our contract pretty solid. Then spend some time building a nice little front end that anybody can use. Then we put our smart contract out on a public network. We deployed it publicly, which you shouldn't do without writing a bunch of tests. We should have written tests. And then we were able to build a front end around that smart contract and put that front end all the way out publicly. So within a minute or two, I will have a link, a URL, where anyone can go use this app that we've just created. And it was pretty fast. I think that was a pretty quick build on building an app. But also we hit a lot of these like main points and these kind of like humps to get over. If you're staring at Solidity all day and you're figuring out how am I going to make an app that people can use without using Etherscan, hopefully this is like a really quick way to get you to building apps that your users can use. Any questions here? Do we want to tinker with any of this stuff? Any lingering thoughts on process or anything?
That guy.
Yep, exactly. Hackathon starter kit. Yes. Thank you. Awesome. That's good to hear. Yeah, so if you are out there, and even though, yes, it is a hackathon starter kit, this is also a production app starter kit. Like this app could go out to production and, barring some stupid thing that I did in the smart contract because I didn't write any tests for it, this is like a production app that's ready to go. This allows you to connect, let's disconnect and let's connect, our Rainbow wallet or our MetaMask or anything else, right? And it'll have us switch to Base, right? This nice little, hey, you're on Ethereum, make sure you use Base. Again, like ENS names everywhere, ENS avatars, just a lot of these things that you're going to have in your production app, we've put into Scaffold-ETH, and we've tried to get it so you can quickly build your app with all of those like bells and whistles you're going to need, but not too many bells and whistles. Like we're not adding the graph in here or anything that's like too far, but the graph is nice. You might want to add that next, but we want to get you to, okay, I have an app that people can use. What do I need now? And that's like, it's not just a hackathon starter kit. It's also like a production app starter kit. And if you're thinking about building an app that people are going to use that is backed by a smart contract, this is a really great way to get that app in people's hands quickly. Here is the app. It looks like it's deployed. Who knows? Oh, wait, maybe that was oh yeah, no, there it is. Yeah, who knows? There it is, right? And then if we go ahead and kind of log in as MetaMask or whatever, it should be us logged into whoknows.app on Base. Ooh, okay, I have some money. I have enough money to pay. And what's interesting is since I'm the delegate, the money's going to come right back to me. So we could dinker around with this, right? Now I could say hello world, and I can send in the price. And if everything works, I should only pay gas. The money should go in and come right back to me because I'm the delegate, right? Let's see what happens here. Yes, yeah, exactly. Yeah, and then I get all the money back. I should have called it rug or something, right? Like call it. Yeah. Okay, let's see if this works. Oh, and now the price is up, right? Our price curve is working. Uh-oh, I think I lost headphones here. Oh no. Oh well, we'll go no headphones. And then let's grab this, paste it in. Hit send. Now the curve has gone up. Now we're paying $3, right? And the money's all coming back to me, so it's hard to see that this is actually happening. But now the price is going up, right? We have this really nice price curve. We have this delegate system, and it's working because I'm not losing money. Now it's $3.24, right? Cool. Okay. Any closing thoughts here? If you are a builder, go use Scaffold-ETH. It's scaffold-eth.io. I think if you just Google Scaffold-ETH, you'll find it. If you're just getting started, go to Speedrun Ethereum and speedrun through all these concepts. We've given you the aha moments, like compressed into a really tight curriculum. And then check out the Build Guild. We're funding people. We're building lots of prototypes. We're building lots of educational material. So reach out. Let me show my Twitter real quick just to get the Twitter. This guy right here on Twitter. Come find me and follow me and reach out. My DMs are open. Hit me up. If you really want to get weird, you could go to this URL and set the greeting and send me $4 in base. Heck yeah. I would love to see some builders out there building more apps. Reach out if you have any questions. There's a great team behind Scaffold-ETH 2 supporting this thing. Put in some PRs, put in some issues. Yeah, hit me up. I'm always around. Thanks for having me.
Perfect. Perfect. Okay. Thank you, man. Take care. Bye bye.